If you were away, this is the third talk of this block, and I will talk about Scala collections, and I will use an example of extending map. And there will be questions at the end of the talk, so please keep focused. My name is Szymon Matejczyk. I'm engineer and data scientist. I'm a Scala fan since Scala 2.8, and I also like graph processing. I used to be a PhD student, and I'm also an open source contributor and an enthusiast, and I've got a portrait done by Van Gogh. It's himself. Okay, so the problem in the presentation is that, the problem has few years. So a few years ago, when I was starting with Scala, I wanted to have something like a grid. So a grid is basically something like a board that has some coordinates, and you've got some values associated to the coordinates. So it's something similar to map from tuple of integers to some value v, but there is one addition. The function row that takes an integer that is the first coordinate, and you want to have some form of iteration over the values in the map having this first coordinate fixed. Is that clear and simple? Yes or no? Yeah, I think so. Is that a task for beginners? What do you think? Okay, so I was a beginner. What do you think is the most common error Scala beginner programmers make?
Extending collections.
Okay, extending collections. Let's be more general. So when I was thinking about myself, it was idealism and courage. So that's what made me to extend Scala collections. Okay, but what are the collections? So we need to recap what are the collections. So we actually have a traversable trait on top of collections. So traversable is basically everything that has for each method. Then we have an iterable trait. So iterable is anything that can give you an iterator. And there is seek, set, and map. And in this talk, we are mostly interested in map. Okay, whoa, sorry. We are too far. Okay, here we are. Okay, so, but actually collections means immutable collections and mutable collections, of course. So I was a beginner, so I've of course chosen to extend immutable map. So that's the hierarchy of immutable collections. So it's basically the same, but we also have implementations. In map, we've got hash map, tree map, and list map. Okay, but there is something more. I want to extend map, but there is actually 3 maps in Scala. There is immutable map, mutable map, and Scala collection map. So what is it? So Scala collection map is the most general trait. So that's the map that does not necessarily need to be either immutable or mutable. Okay, we will see that. Okay, so what is immutable map? That should be simple. So immutable map is actually something that extends iterable with commented out genmap. Oh, that's the Scala code you use, 2.12. So it extends also Scala collection map and immutable MapLike. Okay, what is immutable MapLike? Oh, Scala collection immutable MapLike is actually something with a lot of type parameters, but it's Scala collection MapLike with parallelizable. Okay, what's Scala collection MapLike? It's here. Oh, or let's look at it from different perspective. So we have Scala collection immutable map, Scala collection immutable MapLike, Scala collection map, and here the arrows are the inheritance. Scala collection MapLike, Scala collection gen MapLike, Scala collection gen iterable like, Scala, oh no. Okay, so to understand this, you need to know two important naming conventions in Scala collection. First one, so there are two types of traits in Scala collection. There are traits that have the suffix like, and they are more like implementation traits. So they contain implementations of collection operations, and there are all the others. And also, the hierarchy is quite deep. So you've got mutable and immutable, then collection map, then gen map. So the gen prefix is on top of hierarchy, and everything with the gen prefix can be also a parallel implementation of a collection. So gen is for parallel collection. Okay, so now we understand that immutable map is actually something that has some implementation in MapLike, immutable MapLike, but also it implements the interface Scala collection map and uses some of the implementations from Scala collection MapLike, and some are common also for parallel maps. Okay. Yeah, so we know this now. So yeah, now it should feel a bit more easy. Okay, again the problem. Okay, so let's start with an interface. So we define an interface grid that is immutable map, and it has one added method row. Simple as that, right? Okay, and we've got an implementation of a grid that is actually a nested grid that has that keeps the state of the map in a nested immutable map. We will use hash map for that. Okay, so let's get our hands dirty so we can implement the methods. Oh, IntelliJ helped me to do this actually. By giving me the methods I need to implement. So, row is quite easy. I take the outer map and I iterate over it. Nice. Then we've got get implementation. Nice for expression. I can use monad word in my talk, the last one. And we've got iterator. That may seem a bit complicated, but it's actually unpacking a tuple of int and tuple of int and v to a tuple of pair of integers and v. And there is also the minus method that checks the outer map for the first coordinate, and if it has it, checks the second one and does the subtraction. Okay. And now the last method we need to implement according to IntelliJ, so the plus method. So we try to add key value of type pair of integers v, and since all is ready, what we get? Oh, compile error. Method plus overrides nothing. Why? But IntelliJ, what did you do to me? You generated the definition for me. So actually, if you go deeper, you realize that immutable map is covariant for type V. Okay, but what does it mean? So let's see it in an example. I've got a map from int to cat, and because of the covariance, map of int to cat is also a map from int to animal. Okay, so what's the implementation of plus in map from int to animal? Oh, so plus in the int to animal map has to accept anything of type animal. But a map of int to cat is also a map of int of animal, so the plus in the map of int to cat also has to accept animal, right? Easy. Okay. Oh, so we need to make our trait covariance for v2, and also we need to change a little bit a definition of plus to accept anything that is a superclass of v. Okay, and then we have the implementation, which is actually a bit easier than the types itself. Okay, so to remember the covariance law, I've got a riddle for you. So the riddle is how to put an English key, or in Polish it's called French key actually, into the key cabinet. So if you spot a Scala developer, he will say, whoa, what's the problem? If the cabinet is immutable, you just put it, right, somewhere. Oh, here's the code. So I've got a key that is either an English key or a door key, and I use immutable map, that is cabinet, that maps a number of a key to a key. I insert some keys to the cabinet, and then I just insert somewhere an English key. Yeah, that's a compiling Scala code. Or to illustrate it more, I can give you an equation. I can remember a talk by John Pretty a few years ago on Scala when he was showing quadratic expressions, equations, and analogy to list. And so here is my equation. You just add an English key to a key cabinet and obtain a cabinet for any key. Okay, or to put it a different way, you can change a key cabinet into a toolbox by adding an English key. Whoa. Okay, so let's make a test and finish this talk. So I made some tests. So I test basically adding elements and retrieving them, iteration, adding a superclass, row iteration, so my row method, and everything looks good, right? Okay. Done. 13 minutes. Next day. Next day I wanted to use filter method because I extended map essentially to have all the comprehensive API, for example, to have the filter method. So I used it. And what I obtained when I used the filter or on my nested grid, it wasn't a nested grid anymore, it was a map. And then I couldn't use my row method. Oh, that's not what I thought. So why is filter method not working? And you can imagine that it's the same with take, drop, and similar methods. Okay, so we've got the implementation of filter method that is actually in traversable like. I will not show you the hierarchy again. You have to trust me. So the filter method actually uses another method, new builder. So it starts building a builder and then just filters and adds the elements. Okay, where is new builder implemented? Yeah, you can find it in actually MapLike. Right now I don't remember if it was, oh, it was Immutable MapLike. So I've got the new builder implementation that results, that returns something of type this in Immutable MapLike. And actually this will be the same as wrapper here. So my filter method will return the wrapper, so the this. Okay, so that's why, because I'm using the new builder from MapLike, I have something that is only a MapLike returned here, and that's why it's not an grid anymore. Okay, how to solve the problem? So actually what I need to do is I need to explicitly inherit from MapLike and specify this type to be a nested grid or other type of grid. Okay, and if I do this, I have a filter method that returns a grid. Great. Is it okay right now? Actually, not perfect, because then I want to use the map method or flat map. And it's not working. Why? Because it's also implemented in a bit of other way. So actually, map method uses something that's called CanBuildFrom. If Martin Oderski was working with Java Enterprise, he would just call it builder provider. Actually, and if you know that it's a builder provider, it may give you some idea. So actually, what is map doing? It has an implicit CanBuildFrom, uses it to create an empty collection, and then adds element to this collection. And actually, this CanBuildFrom means that I can build something of type dat by appending elements of type B that are taken from wrapper by using the for each method. Okay, so actually all I need to do is to add an implicit definition of CanBuildFrom for my nested map to the scope. And I can do this in the companion object as follows, right here. Hopefully I can use the mutable map builder. There is already there that will be the builder for me, because it's this map builder. If I define it using my type, it will use my plus method and my empty method to create a new builder of type nested grid that I defined. Okay, are we done? Not actually, because there are some other methods in collections. So, and I like them. So this is, you can use on map a method with default, and it's, for example, nice to have some kind of sparse matrices when you want to have, for example, 0, the default value of 0, or you want to have like a diagonal. So we need to have a method with default, but again, if I used the with default method implemented already, I will have the return type will be map and not a grid, so I will lose the row method. Okay, so now we try to add the with default. So actually, how to do this? If you look into the code when it's defined, and it's defined actually in Scala collection MapLike, and then in the companion object, with default has to return a nested grid. And to do this, I need to have a class with default that actually is a nested grid with overwritten method default. But it also needs to have all the other methods that are specifically for this collection. Like this. I needed to copy, paste it, and change the return types in many places, but it's the way it's implemented in the collection. If you look at the hash map, you can find a code block like this, and all the other places too. Okay, so let's recap. What do you need to do to extend map? So just 6 steps. First one, you need to understand the type hierarchy. Second one, the simplest one, implement the logic. Then be careful about variance and type bounds. Then you need to change the type parameters in the MapLike trait. Then you have to add the implicit for CanBuildFrom. And finally, you need to manually create with default class. Okay. Okay, so that's what happens next. Now we would like to have the mutable map similarly, right? Okay, not this time, hopefully. So, hopefully there is some hope because actually the collections are being redesigned right now. And there is the thread on GitHub about the proposals of new Scala collections. So if you want to learn a lot about collections and implementing weird things in Scala, you can go there and check the discussion. What is also quite interesting is that Oderski mentions some goals for the new implementations. So first, simplicity and readability. Yeah, that's the pain in current collections. Separate interface from implementation. That's the problem of like traits. And the fact that if you want to search for the implementation of method, you usually need to check a few classes. Fix complicated inheritance structure. We've seen it here. And also improve efficiency. Oh, is there a problem with efficiency in current Scala collections? Oh, there is a lot of problems with efficiency. First one is that the mutable map is actually much slower than Java built-in map. The second one, for example, is the fact that all the methods are most of the methods like map are implemented in traversable like just by adding a single element. And of course, it's not optimal in many cases when some batch processing would be faster. Okay, there is also, I mentioned a tweet from Daniel Spiewak, and there is also a proposal that he prepared, and he's a bit deeper, and he is more precise what is wrong with current collections. So it's nice to know that what he thinks is that most of the interfaces are too generic, because actually if you have seek that can be either array, map, seek can be either, map to array, a list, and if you have a method that accepts a seek, you don't know anything about the cost of prepend operation. So if you don't know this, you actually can't write much code that is efficient. He also says that actually the hierarchy for immutable, mutable, and collections are not very helpful, and they induce a lot of boilerplate and complications with types. And he says extendability is important, and also the CanBuildFrom, the builder provider, does more harm than good. Okay, so I told you there will be questions at the end, so here they are. Did you spot a memory leak in my implementation? Did you? Okay, I will show it to you. Here it is. Can you see it now? Okay, so actually, when I delete a key from my map, I go to and if the first coordinate is present, I go here and delete the key from the inner map. So it's possible that I will leave an empty inner map, and that's the memory leak. Okay. Okay, how would experienced Scala engineer tackle the problem? And that's the interesting question. So some of you knew it before. You should never extend Scala's collection. And there was a good talk by Rudiger earlier about collections. And the first thing, don't extend it. What you can use actually is you can implement row method outside of map, right? Just implement the row method and use another map as a helper for the iteration of through a row. Then you can use some implicit conversions. And also you can use composition and don't use the implementations of methods that are already there, like map and others. Just do it by hand. Probably in your map you don't need that many of them. Just implement what you really need. Okay, and so last question, is the extension of mutable map similar? Not quite actually. So probably some of the code would be similar and the knowledge you have after implementing the immutable one, but there is a bunch of like things that are different, starting from methods that you have to override. There is no plus in the immutable map, but there is plus equal, right? Okay, so references. So there is a very good article about current collections. It was from 2010, and that's the first link. It was by Martin Aldersky when they released Scala 2.8. So he did an overview of how are the collections designed. And it's actually very hard to Google it, but once you find it and read it, you start to understand some things that are going under. Also, there is the thread about collections redesign. That is the second link in Dotty. A lot of discussion going on there. There is also the proposition from Daniel Spiewak and other propositions for new collections. So yeah, I encourage you to see it and to read it and to think about it for a while. And you can also find my Twitter handle, so I will post the slides and code in my GitHub repo, so you can come back to it later. Okay, I'm done.